For my project, I will be presenting the deep ocean. I hope you enjoy. The deep ocean, which is divided into the bathypelagic and the abyssal zones. Below the ocean floor is the Hadal zone, or the trenches, and above is the mesopelagic zone, or the twilight zone. The ocean's bottom, or deep ocean, is not a flat, dead zone. The HMS Challenger was really key for the beginning of deep sea exploration. The expedition was between 1869 and 1873. The picture on the right describes where the HMS Challenger found deep spots in the ocean. The crew aboard the HMS would drop a 1,000 fathom long rope, or 6,000 feet, and when it did not reach the bottom, that area would be counted as a deep ocean spot. It was believed at the time of the HMS Challenger that the deeper one goes, the less life there is, until it tapers off at 1,800 feet deep. The HMS Challenger wanted to challenge this, hence its name. First tested the depth of the ocean, which was thought to be shallower at the time, and found that not only was it very deep, in some places more than 2,000 fathoms or 12,000 feet, also there was life in the depths of the ocean. This was a grand discovery and sparked interest in the deep ocean. It was found that these deep spots were not uniformly spread throughout the world. The two researchers, Charles Wyville Thomson and James Murray, were instrumental in the discovery and documentation of the deep ocean. James Murray discovered that there is life in the deep ocean, and the deep ocean should be catalogued and studied. James Murray is the father of modern oceanography. As James Murray once said, "I have no doubt that from however great a depth we may be able to bring up mud and stones of the bed of the ocean, we shall find them teeming with animal life. The extreme pressure at the greatest depth does not appear to affect these creatures. Hitherto, we have not been able to determine this point beyond 1,000 fathoms, but from that depth, shellfish have been brought up with the mud." Charles Wyville Thomson was the lead scientist of the expedition and examined specimens from the deep ocean. He brought to the scientific world and the public eye that the ocean's depths are not dead. It is thought that 95% of the species of the deep ocean have not yet been discovered. Not only is there less known about the deep ocean than of the moon or solar system, it is also less known about it than the mantle and core of the earth. The deep ocean is the least known part of what is known to us about our surroundings. As one researcher put it, basically we know so little about the deep sea that we don't know what we don't know. A lot of things are still being discovered purely by chance. For these reasons, there aren't any graphs on population trends of animal lives in these depths. The bathypelagic zone, 3,300 to 13,000 feet deep, and the abyssopelagic zone, from 13,000 feet to 21,000 feet deep, are what forms the deep ocean. It is amazing that while 90 to 95% of the living space on our planet is located within these zones, we practically know nothing about it. There is no light penetration into these zones of the ocean, so unlike other environments where the producers are the basis of the food chain, in this zone, detritus, dead organic material, is the basis, since photosynthesis does not exist at this level. In the tropics, where the water is extremely clear, there is some light penetration into the bathroom zone. The animals of the deep ocean are not adapted to light and avoid these zones. The animals of the deep ocean prefer the temperate or Arctic latitudes, from 25 to 90 degrees. At bathroom depths, currents are exceedingly slow, and in many areas, bathroom waters deeper than 1,000 meters are essentially stagnant, resulting in lower oxygen concentrations and impoverished faunal levels. The temperature in the bathroom zone is 4 to 6 degrees Celsius, or 39 degrees Fahrenheit to 43 degrees Fahrenheit. The temperature is relatively steady in the upper bathroom zone, but below 1,200 meters, or 4,000 feet, it is essentially constant. The abyssal zone has a temperature of 2 degrees Celsius, or 36 degrees Fahrenheit. The pressure in these zones are extreme, from 4,000 feet per square inch to a crushing 12,000 feet per square inch. The salinity is extremely uniform at 35 parts per thousand, as is everything else in the environment of the abyssal zone. The extreme uniformity of these zones, amount of space, and lack of competition is what results in the animals of this zone looking primordial. Many of these animals have been there for hundreds of millions of years and have not changed over those millions of years. Species diversity is quite high in these zones. These zones are important to preserve because they offer 90 to 95% of Earth's living space and they teem with life. Due to the unchanged nature of this environment over hundreds of millions of years, the species present are like a portal into the past. Just as astronomers look at the stars and see how they were millions of years ago, so can be done with the animals of these zones. Animals of the deep ocean normally live hundreds of years because of their slow metabolism and efficient lifestyle. The amphipod is 360 million years old, older than any animal on land. The amphipod is between 0.4 and 11 inches in length. And like all the other animals of this zone, it has an extremely slow metabolism and efficient lifestyle. A very interesting adaptation of this animal is that its babies are born straight in juvenile form and not as larvae, to save time and reduce the food consumption in the water. An interesting adaptation is that they can eat their exuviae, molted skin, as an adaptation to the extreme scarcity of food in the abyssal zone. One of the other animals in this zone is the snake dragonfish, a scary predator. This is one of the few predators in this zone. Once an unsuspecting fish gets within the grasp of the snake dragonfish, its large jaws will snap shut on the prey and eat it. It will also swallow crustaceans whole. If there is a lack of food, it can eat anything else that is present in the ocean. Like all the animals of the deep sea, it is not a picky eater. Another very interesting animal is the Atolla jellyfish. It is bioluminescent, but unlike most bioluminescent animals, it can produce multiple colors. When it is in danger, it flashes colors of light, which attracts larger predators from around to attack the jellyfish's first predator. This behavior is very helpful for the larger predators to locate food and keeps the jellyfish safe. Another animal of the deep ocean is the anglerfish, which produces its own light to attract prey and eat it. Anglerfish are actually some of the newest animals in the abyssal and bathal zones, being only 130 million years old. This is probably the reason for them being more evolved than the other animals of this region. The extreme sexual dimorphism present in anglerfish is a result of evolution. Anglerfish males can be hundreds of times smaller than their females. Deep sea gigantism results from the relative lack of competition in large spaces available. Squids comprise a large amount of the animal species that live in the deep ocean. One such squid is the vampire squid, so named because it descends on its prey and uses its webbed arms to wrap around the prey and suck it in. This is the region of the fabled giant squid, which was the prominent sea monster of medieval sailing legends. The giant squid evolved for the abyssal and bathal zones and cannot come up to the epipetal zone or the sunlight zone. So it is a wonder how they would know about such an animal. It can reach a length of 30 feet and is an example of deep sea gigantism. Another great example of deep sea gigantism is a colossal squid, which reaches lengths of 15 meters or 50 feet and can weigh 500 kilograms or 1,100 pounds. Despite its enormous size, it eats only 1 kilogram of food per month. Regular diet for an adult human is 1 kilogram per day. The deep ocean relies on the upper layer fish for food. The basis of the food chain is dead animals sinking from above. So when there is overfishing, the food chain of the deep ocean is completely destroyed. It is as if all the planktons were removed from the surface water and destroying its food chain. While the deep water ecosystem is much more steady than the shallow water ecosystem, when the shallow water is affected by its increase in temperature, the deeper water is affected also. It might take longer for the effects of global warming to be seen in the deep ocean, but that does not mean that it will not be affected. Since this ecosystem is by far the most unseen and unknown ecosystem, naturally people do not think about it as much. They believe that it is just a big expanse of lifeless water and there is no need to protect it. That is not true. Another result of global warming is that as the water warms up, it affects current speed and direction, which is dangerous for the abyssal zone. The melting sea ice provides the water for the abyss. The currents from the Arctic take the melted ice water to the bottom of the Atlantic and Pacific Oceans, changing the structure of the deep ocean water. While the animals are adapted to low amounts of oxygen and still water, they still require some oxygen and currents. If the current direction changes, it affects the deep water animals directly and indirectly. If the current changes, the surface fish have to move with the current. The deep water fish and animals are deprived of food. If the water is not refreshed and there is a lack of oxygen, the animals of the deep ocean will asphyxiate. In the last 10 to 20 years, there has been a quota system on the number of fish allowed to be fished. And there are also only a set number of days when fishing is allowed, but disregard of these rules has resulted in overfishing. Most industrialized countries stopped overfishing, but industrial fishing impacts tremendously the whole ocean ecosystem. Global warming impacts the oceans more than the land. 93% of warming is absorbed by the ocean. The ocean is a great filter, warming up much slower than the land, but the opposite is also true. It cools much slower than the earth. It might take longer for it to warm up, but because it takes so long to cool down, even if we stop now the increase in emission of carbon dioxide, the ocean will continue to warm up for some time. If we lower carbon emissions by doing simple things, such as using renewable energies and using electric cars, not only can we save the land environment, we can also save the ocean environment too. While some might say it is too expensive, animal species will go extinct if the current warming trend continues, and animal diversity is priceless. The deep ocean is connected to the shallow ocean, which is connected to the land. The whole world is interconnected, and we must not treat the land and the water as if they're two separate entities. This is my works cited. I hope you have enjoyed my presentation. Thank you.